Hi, I'm Mr. Evans, and today we're going to continue our talk on distance and displacement, except for now we're going to cover what to do when you're given that very challenging problem. In today's situation, the challenging problem is just going to be a whole lot of traveling and for what will appear to be absolutely no reason. And what I mean is a lot of turns, a lot of different numbers to consider. And so I'm going to start by drawing a scenario. Take note that because of limited space on this screen, it's not going to be to scale. But what we're going to do is we're going to travel 10 meters this way. I'm thinking, 15 up, 3 back the way we came, 10 more north, why not, 17 east, 12 south, and 5 more west. Okay, and so now we have this very complex situation in which, hopefully at this point you can solve for distance. If not, we're going to here in a minute. But the real question is, how do you solve for displacement when this is your start and this is your finish, and your straight line from there to here is right there? In our previous examples, the straight line finished a triangle. In this situation, there is no obvious triangle. So what on earth do you do? So let's first do the easier of the two, which in my opinion is distance. So, if you're asked for distance and displacement, distance first. And so we walked 10, and we're just going to follow it. So we walked 10. Next step was 15. Next was 3. Next was 10. Now I'm up top. Plus 17. Plus 12. And then we ended with 5 more. So we have 10 plus 15 is 25. 28. 38. 55. 67. 72. So our distance we walked was 72 meters. Okay, and hopefully you could solve for that before I did. Now this is where maybe it gets trickier. So how do you solve for displacement? Okay, and that's probably going to be a harder one. Now here's what I would do. Okay, I'm going to make 2 categories. I'm going to make it into a table, and I'm going to make a category that is east to west motion and a category that is north and south motion, because everything on here is east and west or north and south. We haven't walked diagonally across anywhere or anything like that. Okay, and so you need to also keep in mind that if one direction is positive, the other direction has to be negative. And so I'll talk about that when we get to it. So let's first start with our first motion right here was 10 meters east. So if this one is east and west and this is north and south, we have 10 meters east. Our next one, number 2 here, was 15 meters north, so we'll put it in the north and south category. The next one was 3 meters west, and so here's what I was talking about, and we're right here now, is if east is positive 10, which we put here, then west has to be a negative 3 because it's going back the way we came. Okay, the next one here is north 10. However, this one is still positive because our first one was north, our second one's north, so we're still moving up and away from our destination. Then we had 17 east, and so east is positive. Next is 12 south, and this is south, so we're moving opposite of north, and so it's negative. And then our last one is 5 west, which is negative 5. Okay, and so there's our 2 directions really, is east and west and north and south. And so what I'm going to do is add up each column. And so let's start by adding up the east and west column. So you have plus 10, minus 3 is 7, plus 17 is 24, minus 5 is 19. So our east and west motion is 19, and that's a positive 19. Though you'll see in a minute whether it's positive or negative doesn't actually matter. And in our north-south motion, we have 15 north plus 10 north is 25, minus 12 is plus 13. Okay, and so now we've narrowed it down to two numbers. And you'll see why this is great here in a second. And so what I'm going to do to give myself some more room is erase our map here off to the left. So if you need to write it down, go ahead and pause the video and draw it if you want. If you're taking notes, if not, I'm going to erase it. So I'll give you one more second. Okay, and if you remember from the previous video, we knew how to solve for displacement if it was made into a triangle. And so now we are going to do exactly that. And so you can see we have 19 east. And so I'm going to draw 19 east. And then we have 13 north, so I'm going to draw 13 north. Okay, and that is our total motion in each direction. So I started here and finished here and finished here. And so if you can remember from our drawing we just had up, this does look to be about what our straight line was in our previous picture. It was slightly north and definitely over to the east. And so now you can see, what have we done? We've made a triangle. And so now we know how to solve for this. And so if you don't remember from the previous video, here's our unknown, and so we're going to use the equation a squared plus b squared equals c squared again. And in this case again, a and b are the two that we know. And so we have 19 squared and 13 squared equals c squared. Okay, so now we're going to do 19 squared, which is 361, and 13 squared, which is 169. Now if you remember when I said earlier that these numbers over here, it didn't matter if they were positive or negative, well that's why, because once we square it, even if this was a negative 19, negative 19 times negative 19 is still positive 361. So these numbers are always going to be positive, which is good because you can only move in the situation a positive direction. If somebody asked you how far away you were from them, you couldn't say, well, I'm negative 10 miles away. What on earth does that even mean? Okay, and so now we're going to do 361 plus 169, which gets us 530, which equals c squared. And so all we have left to do now is square root it. And again, sorry, I just keep running out of room. I'm going to erase our triangle up above. And so the square root of 530 is 23. Oops, still got there. 23.02 equals c. Okay, and so that's our displacement. And again, that was several steps, but you can see that, take the huge map and then just simply divide it into two columns. Your east and west column and your north-south column. Once you've done that, I think the question is drastically simplified and you should have no problem solving it. And that is how you solve, multi-step problems with distance and displacement.